people in Mexico have a lot of inhabitants, mainly distributed across various communities in the southern states of Yucatan, Campeche, and Quintana Roo. These communities live in both urban and rural areas, relying on diverse natural resources such as rivers, lagoons, cenotes, jungles, and fertile lands for their livelihood.
The inhabitants of Mayan community face various energy-related change. In many rural areas, access to electricity is limited or non-existent, which hinders economic and educational development. Additionally, the community heavily depends on firewood for cooking, which not only contributes to deforestation but also cause health problems due to smoke inhalation.
The Mayans have historically had a close relationship with water, using it for agriculture, trade, and daily life. Their knowledge of natural cycles in the marine environment allowed them to establish statements in very strategic bodies of water. The implementation of tidal energy in the Maya region represents a continuation of this relationship with the sea, using a natural resource in an innovative and sustainable way.
Your prototype represents tidal energy. For this type of energy to function, specific environmental conditions must be met. These environmental characteristics are as follows: the presence of water, availability of waterfalls or currents, absence of obstacles that hinder the flow of water, water flow, the height from which the water falls. In this geographic location, it will be suitable to implement your prototype, because this is where the Maya culture is located, and many Mayan areas are near the Caribbean Sea and the Gulf of Mexico, where current coal continuously generate energy. This would allow rural Mayan communities to be supplied with electricity without requiring large infrastructures.
Your system consists of a renewable and clean energy source, since the energy is obtained from the falling water, meaning it does not consume resources or generate emissions. It offers an excellent way to reduce external energy dependence. These production centers are very economical and efficient. It uses water as fuel to generate electricity. It is very safe for the environment.
Model water passed through a container that directs it through a straw reception, a propeller made from bottle caps. These caps are attached to a DC motor whose current wires connect to a LED light.
This process demonstrates how the potential energy of water is transformed into electrical energy. A change or disadvantage our prototype is that building large reservoirs could flood significant land areas, leading to the destruction of nature, particularly aquatic ecosystems. Tidal energy harnesses the natural movement of tides along the Caribbean coast to generate clean and renewable electricity. In the Maya region, this energy source adapts to environmental conditions and helps reduce greenhouse gas emissions. By not relying on fossil fuels or firewood, it promotes sustainable development that respects the local environment and natural resources.
Implemented tidal energy will allow the Mayan community to reduce dependence of traditional energy resources as a firewood and fossil fuels. This transformation has significant impacts, like three of them: environmental, reduce deforestation and degradation, protecting local ecosystems; a social, improves quality of the by reducing export to pollution and decreasing the type of the effort spent collecting traditional foods; and economic, encourage energy autonomy and the possibility of reducing resources, lower other area community deployment.
Yes, Sergio, but also the adoption of tidal energy system in the Mayan community involves certain challenges that must be addressed to ensure the success. The first one is technical training. So community members need to be trained in the operation and maintenance of technology, integrating traditional knowledge of marine environment with modern energy management techniques. Also specialized infrastructure. Although no specific figures are approved, installation requires equipment and structures adapted to coastal conditions. demanding planning and specialized technical support. And finally, institutional support, collaboration with governmental organizations and renewable energy experts is essential to facilitate knowledge transfer and ensure system continuity.
While economic aspects such as initial investment or return on investment figures are not telling, integrating energy into the Mayan community's energy matrix offers long-term benefits, such as energy sustainability that contributes to energy autonomy, reducing vulnerability to fuel price fluctuations and enabling more stable economic development. A better quality of life. Access to a clean and constant energy source allows the community to exchange productive educational and health-related activities, creating a positive impact on overall well-being. And finally, model for other communities. A successful experience can serve as a reference for other indigenous communities facing similar challenges, promoting the adoption of renewable technologies in rural settings.
This argument demonstrates that tidal energy is not only a technically viable solution for the energy needs of the Mayan community, but also provides long-term environmental, social, and autonomy benefits while recognizing and strengthening the traditional Mayan knowledge and relationship with their marine environment.
Also, the implementation of tidal energy model will require an initial investment of approximately 4.3 million pesos, covering feasibility studies, installation, training, and tidal infrastructure costs, with annual savings from reduced energy expenses and the potential sales of surplus electricity. Project returns range between 1.6 and 2.2 million pesos per year. Under these conditions, the investment could be recovered within an estimated period of 2-3 years, making the solution viable and profile in medium term.
In small scale, tidal energy is expensive because it requires specific infrastructure and access to body of water with consistent tides. If a family wants to implement it, the estimated investigation will range from 50 grants to 200 grants, depending on the technological and installation site. To reduce cost, a viable alternative is a hybrid system combination with solar panel with tidal energy, optimize and efficient and return to an investment.
The savings in electricity costs depend on how much electricity energy the system generates and the family's consumption. If the annual electricity savings amount 2,000 pesos, the return on the invest will range from 20 to 15 years, considering possible subsidies or technological improves that reduce cost.
Energy cost reduction can be assessed by comparing electricity bills before and after installation, using energy meters and calculating the proportion of the electricity generated versus consumed. This allows measuring the real impact of the system and its long-term profitability.
Tidal energy presents itself as an innovative and sustainable option for the Mayan community, in addition to contributing to environmental preservation. Its implementation reduces dependence on traditional sources and improves quality of life through significant economic savings. Despite technical challenges and initial investment costs, economic projections suggest a reasonable return period, making it a viable and profitable long-term solution for community development.